All right, this is the second video, step functions. This is section 2.6, Algebra 2 Trig. A step function is just the name of function describing what the function looks like. Let me get an image up for you. This is a step function. You can see how it looks like steps. All right, a step function is a piecewise function that consists of different constant range values. Remember, range means y values. So, constant y values for different intervals of the domain. So for different intervals of the x value, you just have these constant y values, which is creating that step function look. Creating that look. For these x intervals, you have a constant y value between 1 and 2. A constant y value between 2 and 3, a constant y value. This is a step function. Now you can change the steepness of them, you can change how far apart they are, but this is the idea of the step functions. At least what they look like. So, there are two types of step functions. First one's called the greatest integer function. That's this top one. It actually has a few names. We're looking here. Greatest integer function, the rounding down function, or the floor function. You could see all three names. They're just different names for the same thing. But what you're looking at is two different types of notation. You got this full-on bracket, or just a part of the bracket on the bottom. So I think the rounding down function kind of is the best name that describes what it's doing. Whatever the decimal is, you round down to the next integer. And that's kind of where the greatest integer name comes from. You have a number, let's say 3.6. The greatest integer that is inside of 3.6 is 3. You just rounded it down. All right, and the idea of the floor function, well, same idea. Going down to the floor, the next lowest integer. Okay, but again, it's got two different looks to it. I think you'll see each one of these equally the same. I think the book uses both of them. They're used both used. It's kind of weird to have two different things for the same thing. The other type of step function is called a rounding up function, or sometimes it's referred to as a ceiling function. And it's only got the one notation. It's got that little bracket, the half bracket with the brackety part on the top. All right, that's how you're making your distinction. But it's rounding up. So with that 3.6 example, if we had this 3.6, the answer would be 4. You're rounding up to the next integer. Okay? So, to graph a step function, there is a nice way to do this. Basically, what you're going to do is look at the function without the step function notation. So just look at this, y equals 1/2 x. All right, and I'm going to go back to that other picture to help with this. So let me get rid of this red stuff here. Okay, I want this. So I just got this dashed line here. I can change the slope of it, but what I mean by get rid of the step integer function notation, just look at it as a basic line. If you do that, graphing these step functions becomes very easy. So in that example, we had 1/2 x. So I'm just going to change this to be, I can't go to 0.5. Shoot, we're close enough, 0.6. You just draw that line. Make it a dashed line, very light. It's not really going to be part of your function at all. All right. Now, if we're going to graph, that one was the round up function, or the ceiling function. It had the brackets up on top, right? Yes. Okay, so we're just going to change this to be 0.6 x, because I can't get to 0.5 on the other program. So, we're just going to graph 0.6 x. That's this dashed line. Now, it's a rounding up function. So, what we're going to do is, when we go to this integer of 1, I just put this point here, it's a ceiling function. Ceilings are above you. We're going to go above the line. So we're just going to go horizontal over to 1. Now, if you think about the function 0.6x, all right, if we plug in, say, 0.5, 0.5 for an x value, this function rounds it up. So you got 1 times, oops, 0.6. I drew this a bad line. Look how crooked that is. 0.6 is 0.6 times the 1. There's your 0.6 for a y value. All right, go to your next interval between 1 and 2. Go up to, from a x value of 2, go to that line, draw your step horizontally over. Go to 3, go up to that line, draw your line horizontally over. We're going above the line because it's a ceiling function. Okay, so ceilings are above you. Now, just to compare this, here is the full graph of the ceiling function. You can see it highlighted right there. All right, let me get rid of the bad drawing that I did, but you can see we were pretty much dead on. Okay, this is the idea of the step function. If we change this to be a floor function, well, you stand on the floor, so the floor is below you. Do the same idea. All right, you're going to be looking at going below the line. So at an x value of 1, go below the line to that next integer up to 2. From 2, go up to that line, drawing the horizontal part below the graph. Okay, doing this dashed line here. This dashed line, again, it's not part of the graph. This is what your graph should look like. But having that dashed line there, it gives you that guide of where the steps should be. Okay, so I don't need to put it back on here. It was already there. So let's look at this example for the step functions. The cost of parking at a local garage is given by that function. All right, you can see the brackets here. We got ourselves a rounding up or a ceiling function, where h is the number of hours that you park and c is the cost in dollars. Find the cost of parking at this garage for each period of time. All right, so for part A, the cost function is 5 plus 1.25 h. Here we got 3/4 of an hour minus 1. So 3/4 minus 1 is a negative 0.25. The ceiling function rounds that up to the next integer, which would be 0, times the 1.25 plus 5. Our cost is $5. For part B, we have a cost of 5 plus 1.25. We are plugging in 8¼ hours in for h. So 8.25 minus the 1. So this becomes 7.25. When you round that up, 7.25 rounded up to the next integer, that's 8. So we got 1.25 times 8 plus the original $5. 1¼ times 8 is 10. 10 plus 5 is 15. So $15 to park for 8¼ hours. Okay. That's the idea of step functions. One more video for absolute value.